I'm meteorologist Ryan Hanrahan. Happy Thursday. Hope you're having a good evening out there. Want to keep you updated on a couple things. We've got the potential for some severe weather in parts of the eastern United States over the weekend, and we also have a developing tropical storm in the Atlantic. And the tropical storm in the Atlantic is our main focus here with some brand new information. Don't forget, if you'd like to get more of these updates pushed to you right away, don't forget to subscribe to the page. We're hoping to put as many of these updates on tropical weather, any other kind of extreme weather out as necessary over the next couple of months. So make sure you hit subscribe and like the page, and feel free to comment, and I'll do my best to get back to you. So let's take a look at what's going on here with this tropical wave. It's expected to become Tropical Storm Gabrielle over the next day or two. Pretty good odds of it developing. In fact, it looks much healthier tonight than it has looked. Pretty solid cluster of thunderstorms around the center of the system. It's moving to the west, and it's going to continue to move to the west, and as it does, it's going to be encountering some warmer waters, and we expect that strengthening to continue. The storm right now is in the middle of nowhere, to be honest with you. It's about halfway between the coast of Africa and the Leeward and Windward Islands, so it's got a ways to go until it gets to the Antilles, and it's actually moving pretty slowly. Sometimes these systems really can fly along across the Atlantic, but this one is in no hurry to move. Just at about 35 degrees west right now, and it's going to continue to truck off to the west, and eventually it gets close to land. Now, the update here is that today, most of our computer models now, at least the majority of them, are showing an impact to the islands and potentially as far west as the Dominican Republic and Puerto Rico about 5 to 7 days from now. If you were watching yesterday, the day before, it looked like the odds of an impact were a little lower, not zero, but lower. There's some computer models taking the storm to the north, but we've seen a shift to the south, and so it looks like the islands are a little more at risk now than they were yesterday. So here's where the center of circulation is, again, moving off to the west. The hurricane center giving it a 90% chance of developing, so really good odds of development here. And if you look at this cone here, where this red shading is, you head right toward Barbados and up toward St. Vincent and the Grenadines, up toward Dominica, and then eventually heading up toward the Virgin Islands, and if it continues to the west, out toward Puerto Rico and the Dominican Republic. But look underneath that red shading. The colors below, those are the water temperatures, and as the system gets farther and farther to the west, it's going to be encountering some warmer and warmer water. So right now, it's certainly warm enough for tropical development, but the water temperatures will warm as the storm heads toward the Caribbean. So right now, we're looking at about 28.5 degrees Celsius. But as this thing heads toward the Caribbean, you're going to warm up to near 30 degrees Celsius. So some pretty warm waters. That warm water is the fuel. That is one of the reasons why we expect this storm to strengthen. Not the only reason, but one of the reasons. So let's take a look at some of the computer models here. We'll start with the European computer models, and you can see the storm trekking to the west and then eventually begins to turn. But the majority of the computer models now bring this thing awfully close to the islands. There's Barbados, and the Virgin Islands are up here. So mainly the Leeward Islands at risk for this storm as it moves to the west. And the GFS computer models here, let's take a look at what we've got. Again, the storm moving to the west. Some are pretty far south, down in the central and southern Caribbean. But more of our computer models are showing that threat to the islands over the next couple of days. This is the super ensemble, courtesy of Tomer Berg, and you can see the brighter colors. Shows where there's better clustering in our computer guidance, and that shows that the islands certainly at risk here, the Leeward Islands, and then eventually out toward Puerto Rico. So we'll be watching this for you carefully. Again, it looks like an increased chance for an impact to portions of the Caribbean, and then the question is going to be how strong does this thing get as it moves off to the west, and that's what we're going to be watching pretty closely for you. So no real change to the thinking in terms of what the storm is going to do. Its general track. This is a look at the the GFS rather. This is the American computer model. Watch the center of circulation here as the storm moves to the west, and it continues west. It's being steered by this big subtropical ridge to the north, and that ridge is effectively a block, prevents the storm from moving north, and it moving right toward the Caribbean here. So this would be next Thursday, a week from today, the 11th. Storm heading very close to Barbados as a hurricane, and then moving up through the Caribbean, heading toward Puerto Rico by the end of next week. This is next Friday. Notice what happens here. I'm going to back up here. So let's go back to next Wednesday, so 6 days from now. Notice the ridge, these brighter reds to the north. That's the steering flow. That's what's steering the storm to the west. But that ridge begins to break down. And as it does, you're going to see the storm gain more latitude. So it starts to come north toward Puerto Rico. Then eventually it's out in the Atlantic Ocean, sort of menacing off the coast of the Bahamas up toward Barbados, and eventually gets swept out to sea. So this is one of our computer model solutions. So this would be a bigger threat to Puerto Rico and the islands, but that's not to say that it's a certainty. Let's take a look at the European computer model, see what this one wants to do with the storm. So if you look closely, you can find it. It's not very well defined. There it is. Again, moving off to the west. It strengthens a little bit, but it stays pretty weak. Look at the pressure, 1,006. That's barely a tropical storm, 1,006 millibars. That's nothing impressive. And then as the storm crosses the islands, it basically falls apart. There's a lot of dry air around, and for whatever reason, this computer model, the European, doesn't really have it doing all that much. So yes, impact to the islands, heavy rain, some squalls, but this would be sort of the best case scenario, right? So you get some nasty, you get some rainy weather, but you avoid a direct hit by a tropical storm or hurricane. So a couple different options out there, similar track, but just very different intensities. And then another look here. This is the European. This is the AI version of the ensemble, and same basic trend. Big ridge allows the storm to move to the west. There it is. Just follow the cursor, and you don't see a whole lot. There it is. But that ridge breaks down, and it gives it the escape hatch to the north. So same basic trend as Aaron in general, with that ridge guiding it to the west, and the ridge breaks down, the storm comes to the north. The question is, how quickly does that ridge break down? And the storm is going to start a little farther to the south than Aaron did, so it has a better chance of impacting the islands. Let's take a look here. This is a look at the water through the atmosphere, how much moisture is there. We call this precipitable water, and this is the GFS. Here comes the storm strengthening, but as it's doing so, there is dry air all around it. There's some dry air to the south. There's some dry air to the north. So it's in a sort of tenuous spot here, surrounded by that dry air. And so what the dry air will do is that dry air can sort of get entrained into the circulation, disrupt the circulation. So if you want a hurricane, you want a really big area of moist air sort of all around it. So it's not going to be sucking in that dry air, because that's detrimental to the storm to develop. So the GFS does manage to intensify the storm, but again, there's some dry air around, so some caution flags in terms of this thing's strength. And then as it comes to the north, actually the atmosphere becomes a little bit more conducive to strengthening. There's less dry air around near the Bahamas. So dry air, some shear factor in the intensity, so we'll be keeping an eye on that as the storm moves to the west and eventually to the north. So here's the deal. Puerto Rico, Virgin Islands, Leeward Islands, keep a close eye on this thing. I think there is a chance for some impact. Whether or not there's an impact to the United States, the mainland United States, Puerto Rico, different story in the Virgin Islands. Mainland United States, too soon to tell. I think the odds generally of an impact to the mainland U.S. are fairly low at this point. I showed you that ridge breaking down. I'll show you one more time. Let's go here. This is a week from this weekend, so we're looking. This is pretty far out, right? This is 9 days from now, but the ridge has really broken down over the western Atlantic, and so that should give this thing an escape hatch. Not to say it's not going to meander and do some nonsense between the Bahamas and Bermuda, excuse me. But that weakness should be enough to take it to the north and eventually get caught in the jet stream, get the heck out of here. So that's the thought right now. But again, too early to say with much confidence. Things can happen. They can be more subtle steering currents involved, but the general pattern should allow this thing to go out to sea. So we'll be watching it for you, especially if the GFS is right. It becomes like a more significant storm. All right, I want to talk about the chance for some severe weather in New England over the weekend. What I've got plotted here is the surface-based cape across portions of the northeast by Saturday afternoon, and you get a decent bit here, about 2,000 joules of CAPE across portions of central and western New England. And the winds are also quite strong. So I can show you, pop those up. Call an audible here and throw the wind speeds up, and so you've got winds here just above the deck, about 30 to 35 knots. So there's quite a bit of low-level wind shear in the atmosphere, and so that combination of shear and instability with the front coming in from the west, that could be enough to spawn some strong to severe thunderstorms on Saturday afternoon and evening. And this is just one sounding I pulled. This is from central Connecticut, and you can see if you look in the atmosphere, so you've got some instability between the red line and the blue line. That's your CAPE. That's convective available potential energy. And on the right here, you got the wind fields. The winds are coming in from the south-southeast of the surface, but they're veering with height, and they're coming out of the southwest aloft. So you've got a little bit of low-level wind shear here. The deep layer shear is pretty impressive. You've got about effective shear 40, 45 knots. That's enough to allow for some supercells to form. So we'll see what happens here, but there definitely is a severe weather threat, and that severe weather threat outlined here from the Storm Prediction Center for Saturday from southern Maine down through New Hampshire, southern Vermont, most of Massachusetts and Connecticut, then down through New Jersey, and most of the I-95 corridor all the way down into portions of Virginia and North Carolina. So that's the next thing we will be watching. But we'll keep an eye on that severe weather threat on Saturday, and of course all eyes on what we expect to become Tropical Storm Gabrielle as it moves across the Atlantic. We'll keep you posted every step of the way. Thank you so much for watching.